Good afternoon, friends. Welcome to the STP training webinar. The topic for today is Mobile Visual Testing, Uphill Battle for Mobile Visual Regression. Our speaker for the day is Dmitry Vinik. I'm Smita Mishra, a professional tester myself, and I'm super excited to host you all and Dmitry on the STP webinars. Quick information for all of you. The next upcoming conference we have is Fall 2018 STPCon, which will be held at Arlington, Virginia from October 22nd to 25th this year. The complete program is up for your review and selection at stpcon.com. Early bird discounts are being offered until 24th of August. So if you're coming with your team members, don't forget to ask for team discounts. And if you are one of our regular attendees who would like to come back again, we also have alumni discount for you. So do reach out to us should you need any help on the registrations. And the quick piece of information that I have for you is that there is an upcoming webinar, Entrepreneurship in Software Testing, on 25th of July, wherein I shall be discussing some tips and tricks, some do's and don'ts with 3 leading test professionals who have turned into entrepreneurs now. These 3 are Mary Thorne, Damien Synadinos, and Paul Merrill. Mary and Damien are more like independent consultants, whereas Paul runs a bigger team in an organization setup. Again, the link is up for you to review and register. I suggest you go for it. It's going to be very interesting. Also, if you are on Twitter, please share the conference information and about this webinar with your followers and connections. You can also add STP's Twitter handle to your tweets, which is @SoftwareTestPro. You can also note down the speaker Twitter handle @Dmitry Vinik. And right before we start, few housekeeping points for next 1 hour. All the attendees shall remain muted through the webinar. You can type in your questions and share them with us through your question box. We shall take them up after Dmitry is done with his presentation. The webinar shall be recorded and posted on the Software Test Pro site for the attendees to go through later. All right, so let's get started with the webinar today. A very warm welcome, Dmitry. We are very thrilled to have you with us today. And let me quickly introduce you for all of us here. Dmitry is a lead software engineer at Salesforce and has been passionate about software quality since the very beginning of his career. He started out as a quality engineer and was able to bring test expertise into his current software test engineering role to ensure delivery of a high quality product. Dmitry is also a Scrum Master focused on making his team more efficient and productive. His background involves studying medicine and bioinformatics in addition to software and quality engineering. All right, Dmitry, a very warm welcome again, and the floor is all yours now. I'm going to share your screen.
All right, thank you for introducing me. I'm also thrilled to give this webinar. Okay, so great. Yeah, as I was introduced, my name is Dmitry Vinik, and today we'll talk about the visual mobile regression and visual regressions in general. It's been mentioned before, please tweet at me or feel free to send me an email if you'd like, if you have any further questions or any questions in the topic itself. So without further ado, let's actually get started. And first of all, of course, we need to determine and establish what are our goals today and what we'll be talking about. Because from the title itself, you know, it might not be as clear. And so the first and foremost, of course, we will talk about the area of visual testing as a whole, like what it is, why we have to care about it, and potentially how to do it. Then I'll try to apply this visual testing perspective to the test pyramid and explain to you where visual testing actually fits in our standard of testing practices. And last but not least, I'm hoping for all of you guys to either find the tool that you'd like to accumulate into your daily practices or just the concept itself that you can actually learn about and hopefully implement at your workplace. But first, as you've seen from the title of today's webinar, I mentioned mobile visual regression, but it's fairly vague, and I'd like to be more specific on the targeted platforms that I'll be talking about today. And so obviously nowadays, when we say mobile, we of course mean things like iOS, Android devices, but these days we go beyond that, and of course we have to talk about web applications built as responsive apps or hybrid apps. And so we'll talk about all of those and how you can actually use the visual testing with each and every platform that I've just mentioned. But as I mentioned just a couple minutes ago, the mobile is very broad, and even though I'll talk about iOS and Android, I'd like to be very clear that we will be focusing on one particular native platform. And if you see from this graph of market share in the industry between the different native operating systems for mobile, Android is obviously leading when it comes to the market share. Hence, for today, I will be demonstrating native Android in addition to the web applications. I'll mention a couple of things about iOS and what you could explore, and I'll share some code where I actually use native screenshot and visual testing for iOS as well. But we will focus on Android for majority of this presentation. So with that out of the way, with our kind of focus for today's talk, I'd like to just approach testing from the top level first and kind of ask you a question or try to get you to remember, how do we usually organize our QA effort? And if you get to forget that, usually the way I remember it, it's something with 4 sides to it. And obviously when you hear 4, it's also called testing quadrants, or as they also called agile testing quadrants. And so for today, we'll be focusing particularly only on first 2 quadrants. So we'll talk about unit and component testing as it's applicable to visual testing. And we will also focus on discuss some functional and end-to-end test scenarios for visual testing. So we basically will stay on the left side of these testing quadrants when it comes to the organizing a testing effort. But of course, if you go into more details of the overall QA expertise and practices, there's obviously something that you have to remember on how to organize the test itself. And of course, this is something with just 3 sides, if you were to remember it. And of course, I mean the test pyramid. You can also guess it from the goals that I have established at the beginning of today's presentation. So as we all know, when you talk about test pyramids, you have to mention that you have to have the highest number of unit tests, which basically match the criteria of being the least costly, in the sense that you spend least amount of time maintaining them, writing them, and obviously they also take the least amount of time to run. So they're giving you the fastest feedback, which is essential for the engineers, and because you can run them in within a couple milliseconds. But unfortunately, they don't give you as much confidence in the product, so the fidelity level that this test give you is pretty low. If you were to move on to the next step when it comes to the test pyramid, people sometimes call it service tests, integration tests, but the gist of it is that it involves multiple units of work that you're trying to test. And if you talk about mobile testing as a whole, usually when they say unit tests, they mean you write and run something just on desktop level, so you don't need the actual device. But as soon as integration tests come in, you have to have either emulator or a real device. So basically, these tests are more involving and frequently require an actual app to be running. So again, they're kind of slower and higher cost and a better fidelity. But obviously, last but not least, is end-to-end tests, which ultimately are the highest cost in terms of developing them, maintaining them, and ultimately they are the slowest ones comparing to the unit tests or integration tests, because they are requiring you to write the test and run it for the entire user flow. So if you were to log in, test something, and then log out, so it will be pretty slow comparing to the other two levels. But fortunately enough, it gives you the highest level of fidelity, meaning the confidence level in the overall application is the highest on this level of pyramid. But as you can see, as it gets steeper to the top, it means that you should have the least number of end-to-end tests and the highest number of unit tests. So that's overall the gist of it. I hope that we're all familiar with this kind of theory. But this is all theoretical. When I talk about something, when it comes to testing, I like to be more practical. And with that, I actually like to test something. And I've been talking for the past 10 minutes, and obviously something on my mind is that I get pretty thirsty, and probably many of you are as well at this point. And so imagine we have a drinking glass. First, when we have a drinking glass, we obviously just take it and examine, does it fit in my arm? Is it like round shape? Can I actually, push something into it? And so what I do next is I actually pour water into the glass. So now I have a glass full of water. And then obviously, since my ultimate goal is to actually drink that water, my final action will be drinking this water from the glass, and I end up with empty glass again. This might be like, why am I even talking about this? But if you were to look at each and every step that I just mentioned, this is actually the first level was a unit test where I just examined the glass itself, whether it fits into my arm. That's basically the unit test. When I got into the pouring water into the glass, I integrated 2 units when it was water and the glass, so I got integration test. And after I actually drank that water, I ran through this use case of me drinking something from the glass, which ultimately is called end-to-end test. So basically, we just implemented the test pyramid in an everyday scenario. So again, that's fairly simple, a bit less theoretical comparing to just looking at the pyramid. But you might be saying, are we done yet? And I would obviously say no, because it will be a very short webinar then. So imagine you have this sort of glass. So this is a still drinking glass, but you can notice that there is something wrong with it. There is actually a crack right in the middle. So, but I still want to, I'm still thirsty. I actually want to drink some water. And so what I do is I have my glass. It still fits in my arm. So basically it passes the unit test. Then I pour some water into the glass. Even though some water obviously leaked, I still get to hold some amount of water in the glass itself. And even though it was probably unlikely, I was able to drink this water. Most likely I got some glass as well while drinking it, but ultimately I was able to drink something. So as I've mentioned before, it still matches our unit integration and end-to-end flow. So functionally still able to drink the water, still kind of, my thirst was satisfied to some extent. So that's great, right? Test pyramid was satisfied. But you still might be asking yourself, and I hope you are asking yourself, that we might be missing something here. That functionally it's possibly working, but there's something wrong here. So if you were to compare the two glasses with the water, yes, they are functionally the same, in the sense you can drink water, but visually at least, they are very different. You can see that this crack on the right glass, wasn't just affecting the visual perspective of the glass itself, it actually ultimately had integrity concerns for the glass itself because some water was leaking out. So it started with just visual crack and ended up affecting the amount of water the glass was able to hold. But the water itself might be too abstract, and what I like to think about it is as a user experience. So if in the full glass, fully non-cracked glass, you have a glass full of water, on the right with a crack in the middle of the glass, you actually have some user experience leaked out, and you left with just the smallest amount. So you can also think about it from that perspective. So it started with just visual effect, ultimately resulting in some sort of a functionality degradation, but you have to go beyond just testing this end-to-end flow of me drinking the water. You have to go beyond that and do some visual testing. So with that, to actually solve this problem, this is where the visual testing comes in. And visual testing basically trying to tackle this visual content problem where you are visually the two drinking glasses were different, and I want to make sure that I noticed I have a test to track that visually that cracked appear. It's not just functional that someone was able to drink the water, not just that API returns me returns me the value. I want to know what that value shape was, how it looked like. Have some sort of approval testing, as it's also called. The visual animation is also a common problem visual testing trying to solve, especially if you have any SVGs or GIFs on your web app. You really have to test those visually because it's almost impossible to test them in a functional matter. The page layouts, especially if you're working with responsive design, where you have the same web application that, depending on what device you're using, whether it's mobile, tablet or a desktop, the same application would arrange the elements on the page very differently. So this is what visual testing is trying to test, because although your feed component on the page might behave the same way on the desktop or on mobile, visually where that feed is located is essential for your user experience. And user experience nowadays is very important for customers and your business success. And so with that, I'd like to make a statement that functional manual testing is difficult, but still possible. But visual manual testing is nearly impossible. I don't like to talk extremes, so obviously I tend to say it is impossible, but I have to prefix it with nearly impossible. And the way I'd like to determine and explain that is by using science. It's always great to look back at the actual research that's been done by people much smarter. And so there have been so many papers written on this topic. Some people call it change blindness, some people call it partial blindness, perceptual blindness, and so on and so forth. But ultimately, the outcome of this research has been done by many professors out there. The idea is humans have a very hard time figuring out and seeing the smallest changes on the picture, especially after looking at it for a long time. You probably remember maybe from the younger days where you used to have 2 images and there was a task, find 10 differences in between those images. That was fairly simple. But imagine your developer was changing the CSS, the CSS of the web page, and as a result, the image was moved by 1 pixel. There is no way you'll be able to see that 1 pixel. And so that's the only way to tackle it, is by you actually having the automation, the help of the machine with this sort of technical task. And so the conclusion again to make here is that visual testing requires automation, because otherwise it's not just the effort, the time that we spend, it just, as I mentioned, it's nearly impossible to be done by humans. But again, yes, the automation, as I've mentioned, the way we structure our overall testing work is that we follow the quadrants, we follow the test pyramid. And so again, the question here to ask, where does the visual testing fits in our day-to-day test pyramid? And my answer is on every single level that you can fit the visual testing. And yes, we have the test pyramid that we probably all used at some point, but I would say there is also visual test pyramid that you can apply at your work. And the visual pyramid will look something like that. So, but the way I'd like to talk about it today, again, back to the title of today's webinar, it's uphill battle. So I'd like to approach it not just as a pyramid, but as a hill that we're trying to conquer. And let's say we started our journey on this first level, our journey to the top of the hill or of the pyramid. So we would start by talking about the CSS and DOM tests as it comes to the visual testing. And that first level, again, since it's still a test pyramid, will match the same criteria of the lowest cost, highest speed, but unfortunately the lowest fidelity or the confidence in the quality of the software that we are testing. Then we will move on to the visual component testing, and we will wrap it up with the page tests, basically this end-to-end visual testing that, of course, will also match the same criteria of being the most costly, the slowest, but give you the highest confidence in the quality of your overall product. And so without further ado, let's actually start our climb. So if you look at the CSS and DOM tests, before I would go any further, I have to establish the demos and the testing that we'll be doing for. So we have the same application that developed as a responsive app that I've used React to develop that. We have a hybrid app that I used the React Native to develop. I also wrote it for the Android using Java, and last but not least, I use Swift to develop the same application for iOS. I'll share the code for you after today's talk, but the idea is for this first step, for the CSS and DOM tests, we will mostly focus on the web applications of our app. It will be using the responsive app and the hybrid app. And I'll demonstrate the application itself in a minute. So to start with this CSS and DOM tests, I have to mention something called snapshot testing. And what's better for showing you something than just demonstrate that in action. And so to demonstrate you the snapshot testing, I would get started with, all right, something called jest. So jest is basically the, let me see. All right, great. Okay, first of all, so jest is the test framework that frequently used by developers who work with the virtual DOM. To demonstrate you what the virtual DOM is, so this is our application that we will be testing today. So I'm trying to be very, polite here, like, since I'm in Canada, so I say hello all the time. So I say hello to Canada, but obviously, as I work with America a lot, I have to always be prepared to say hello to America. So again, it's a very simple app that basically has one action. On a click of the button, it changes the flag and the label. But the idea that I'm trying to make here is that virtual DOM, which is basically very different from your standard application that you just tried statically as part of the HTML. If you were to, for example, inspect this page and to look actually at the body of the page, you would see nothing. So basically, there is no DOM here that actually shows you the flag, the label, nothing. But if you were to inspect the app itself, you would actually see that there is something in here. There is a content, there is the image, there is this flag, there is the label, and obviously there is a button. So this is what the virtual DOM is. As part of the application, it generates this DOM dynamically for you. But if you were to just try to inspect it statically, like, just open it in a view source, you would not see that. So that's basically the gist of what the virtual DOM is. And obviously, as with anything, that introduced quite a bit of complexity. And and that complexity also comes with some benefits. And the benefits that I'll be talking about today is that when you're working with the virtual DOM, you're able to develop applications as components. So let me make it a bit larger for you guys. So, all right, great. So this is basically our overall application. Let me show it to you. So the idea is I'm using React to develop this app. Basically, you have to define, first and foremost, you have to define the component. In React, it has a constructor, it has a state. That's not very important for us. But the idea is ultimately you can specify the DOM that it would generate, and this is what would actually appear on the page depending on the state your application is in. But this is not what's important for us. What's important is just showing you the gist of it. For example, imagine I have the component, change country. Change country is basically nothing more than just a button. It's basically, if you were to go back to the app, it's this guy, this switch country. So that switch country button is generated by me in JavaScript defining this change country class and just specifying the kind of a DOM that will be generated. So so again, with this sort of virtual DOM, I'd like to have a snapshot of that generated DOM of my application and be able to compare it. This is what the snapshot testing is. I'll basically render this snippet of code, save it in a separate file, and try to compare it. Almost like if you were to have, text A and you were to compare it to text B afterwards. And to show you the actual test that I would write in this jest framework that I've mentioned, it would look something like that. Fairly simple. I define my test, I name it, then I would say render me the component, the change country component, which is I defined here. So here you can see that it's very close and it's in the same package as the development code, the code itself. So tests are very closely integrated with the development process, hence it's on a unit level of the test pyramid. Then what I would do, I would format the result and I would basically assert it. These basically couple lines are the same almost all the time, so they're not very important. What's important is how easy and fast I can run these tests. So if I were to, write this single this quick test for me, and I were to just do, in my case, npm test. So what it would do for me to run it, you can see how quickly it ran, and give me some, output results saying that, we just ran it. It took 13 milliseconds. And if I were to actually look at the snapshots, they are actually in the folder called snapshot, it would generate me something like that. So it will basically have that DOM saved. Again, as I've shown you, you can't simply view the source of your page and then compare it. You have to generate it dynamically. And with this framework, you're able to do that and compare the result to if you were to make any changes. And it will save class names, the click event, and the style itself. I haven't shown you this, guys, but you can actually define the style of your component as well, which is very important. It's very similar to how you would write it if you were to have a separate CSS file. And so, my test at this point is fairly simple. So it saved this predefined virtual DOM. But imagine something changed. The developer changed, for example, the color. So it used to be white, and now it's a black color. And so if I were to run my test, basically it will run it, but you can see it failed. And what I like about all these sort of new test frameworks, especially the targeting developers, it gives you the feedback right away and in a very nicely formatted way. It tells me exactly what happened, what failed. I don't have to go into the file itself to find it, which I can, but it gives me the output right here. It tells me the color has changed. So you can see again that I was able to match this criteria of it was quick to write this test, again, the lowest cost. They run very quickly, so they give me feedback as soon as possible. And, but still it gives me very low fidelity in the overall application. It's on a very low level and targeting developers. But that's basically the snapshot tests. But if I were to go further than that, you still might be asking, is it enough to just have these snapshot tests? And unfortunately, no. And to show you why, again, I have to go back to my browser. And so this responsive application I've developed with React, as I've mentioned, it reacts to what device you're looking at. So for example, in a tablet or in desktop, I would have flag, name, and the button. But if I were to go to, let's say, my phone, yeah, if I were to go to the phone view, I would basically have the label and the button, no flag. So it's basically optimized for the phone. But if I were to go in between the dimensions, so right now you can see it's 320 to 568. Frequently, when you have a responsive app, the problem is not in the states like desktop state, tablet state, or mobile. It's in between those states. So in the point where it's changing from desktop to tablet, from tablet to mobile, in between those states, this is where frequently the visual regression bugs occur. So for example, if I were to say something in between, what happens is I don't see my flag, I see my button, I see my label, but the space is still occupied. This is awkward, to say the least. And it happened because it's right in between that desktop and the mobile state that I was writing my app for. So, and basically affected the overall application. And if I were to just do the snippets, those snapshot tests, it won't be enough to catch this problem. And if I were to go further to actually test that and figure out how to approach it, because this is a problem, obviously, the solution would be to actually go further a level and go to the visual component tests and have the actual application in place. Don't just have that auto-rendered single component. I have to write tests for the actual app, have this integration level testing in place. But again, I have to take a step back for a second and clarify something I've already talked about, and this is called component-driven development. It has lots of names. It's sometimes called pattern libraries, but ultimately the component-driven development, it's when you develop an app built of components. So it doesn't get simpler than that. And the idea that you're trying to build reusable components that can be ultimately they encapsulate in the logic of each individual element. For example, in my Hello America use case, the Hello America would be just a label component that has a different value, different text depending on what country I'm showing it to. It's all about those components being composable, because if I have a label, I have a button, I have a flag image, I want to be able to combine them and create an app consist of these three components. And they also have to be semantically correct, in the sense that if I create a component that will be reused by someone, I would better call it a button and don't just call it something like change button just so it can be reusable. It has to be generic enough for other people to use and understand just from the name what this component does. But to give you more insight, again, looking back at our app in place, the Hello America, imagine this is an app built on Android for the Android. So the this top level component is called text view. If you're familiar with the Java for the Android, it's a text view.java. So the same component, I just changed the value in it, the text. In the middle, I would have an image view component. That the only thing that I do here, I just send down the resource to the pointed to my image, to my flag. But at the same component, image view is exactly the same. And last but not least, switch country is just a button that I bind to a specific action and a label, switch country. So ultimately, this is what the component-driven development is in practice. It basically, you can see that it's encapsulating the logic. It's composed of multiple components that are semantically correct, in the sense, text view, it's a view that contains text. Image view, it's a view that contains image. So that's basically the gist of what component-driven development is. And I really wanted to clarify that, because in many talks right now, and even in mine, I've mentioned the component tests, visual component tests. So I want to be very clear what those components are and why they are there. And so the best way to actually describe it and show it to you outside of the application I've developed, it's something called Storybook. And I find Storybook is a great tool for visual testing on a component level. It's very good for the developers. And the idea is it acts as a library of your components. Also, it acts as a testing ground. You can test different states your component can be in. It behaves as a style guide. It has documentation in it. And it also can be used as a IDE that you can use to develop and enhance your application. If I were to give you a quick glance, what I like to do is to look at Airbnb Storybook. Storybook as a whole, it's open source GitHub project you could all download. It has lots of enterprise support, snapshot tests, very easy to write for your own scenario. But I'd like to really show you how the Airbnb did it. So, for example, they have a component called date range picker. You can actually interact with it right here in isolation. But the cool thing about it is that they also have different states you can pick from. So it was a default. I can also have Persian if I wanted to. I can have non-English locale if I wanted to, but still, I can still interact with it. And it just shows me how the labels are, and I could technically write my visual tests for it, taking snapshots, and so on and so forth. So this is one of the tools I'd like to show to you guys, that storybook that you can enhance and use if you wanted to. But to talk about actual visual component tests, again, for today, the testing demos we'll have for this step, we'll have all four: the responsive hybrid apps, Android and iOS, and we'll try to exercise all of those for this step. And obviously, we'll have to begin with the screenshot testing. And the screenshot testing, all the frameworks out there, they're based on few simple steps, few simple components. They have a view loader, basically something that loads the component or the application. It has action driver, something that interacts with the app. And the comparison driver. Basically, after you take screenshots, it needs to be able to compare the screenshots and give you the result. Did it match? Did it fail? What was the threshold failure that you were accepting? And so obviously I have to start with the kind of older tools, the Phantom CSS, something that people used for the longest time. Obviously, it uses Phantom.js, which is currently deprecated as basically the base to load the browser. It uses Casper.js to interact with the page, and it uses Resemble.js to actually compare the screenshots. You can also see even from the icon of the Resemble.js, it has this purple color. If you've ever seen the visual tests, you might have noticed that that purple color is all over the place. So it might have started from here. If I were to actually demo that to you, I would basically go in exit presentation mode. And if I wanted to open my, no, not this one. Yes, the calculator. Great. Yes, so that's the one. So basically, it's a small application to actually demonstrate you the app really quick. It's slightly different from what we've done. This one is basically a small calculator, which I'd like to basically written in HTML5. Very simple. You can do like 1 + 1. It gives you the value. So no JavaScript, just pure HTML. Very simple. You can see that arrangement of these values is very similar to what you would have in any sort of calculator. So if I were to run and write my Phantom CSS test for it, the way I would tackle it, let me presentation mode. Great. So obviously I would have a Phantom CSS reference. I would initialize my test. I would initialize my Phantom CSS, which is not very important for us. What's important is this Casper.start is basically where I initialize the URL I want to work with. If you've ever written WebDriver tests, which I would imagine you have, this is basically very similar. I'm starting with the URL. Then I have to establish the resolution, which is, again, very important if you're working with the responsive apps, because depending on the viewport in this scenario, it would have a different states of your application. And then I would write the tests themselves, which can be fairly simple. If I wanted to target the overall body, basically the overall calculator, I would just write saying, wait until the body of the calculator is loaded, then just take a screenshot and name it simple calculator body. So very simple. And then I tackle timeout if needed. So nothing special there. But imagine I wanted to do something like that, more complex, where I basically say, open up calculator, press 1 + 1, then wait until the result shows up, and only then take a screenshot. So in this flow, we have two tests where we just take a screenshot of our overall calculator, and we also take a screenshot of specific region that performs calculations. So I showed you the calculator just now. This is the arrangement. But imagine something went wrong, and our calculator now looks something like that, where while you still have the same buttons technically, so 1 + 1 still works, you can see that all the arrangements of the buttons basically is all messed up. It's all over the place, completely different. So functionally, you can still see that I'm able to do 1 + 1 = 2, but visually, they are very different. So if I were to run my tests right now, if I wanted to run my tests, okay, great. So if I wanted to run my tests, let's make this a bit larger. And yes, so basically run my npm test. Again, that one is fairly quick. What again I like is this, the feedback I get. It tells me, it doesn't seem like you ran any tests before. Is it your first time running this test? So that was a good feedback for me that just tells me, oh, you probably haven't done anything before. What it does, it generates these screenshots for you for two use cases, two different tests that I had. Oh, that's too big. Yes. So you can see that it took a screenshot of the calculator. And it also basically the second use case where it does +1 + 1, and then it takes a copy. They basically saves the result tab to see how that looks like. But as I've shown you before, that rearranged version of the app. Imagine in our test, I had something like pointed to that, all over the place buttons, and I were to run my test for it. Again, test will be fairly quickly run, and again, it fails. It tells me that it failed with a 4.29% mismatch, which you can also alter. What do you call a failure? That's actually good one of the problems with visual testing, you have to know what the failure is. So and then it generates you more screenshots, and it tells you, what actually the failure is. That purple color I've mentioned, it shows you what the differences are, and it even shows you that now AC is here. It used to be 7. You can also see different, the new screenshots that were taken. So that's basically the gist of this visual testing on that old tool that people probably used all over the place called Phantom CSS. Backstop.js, it's much newer tool that I personally really like. Again, it uses headless Chrome as the view loader, Puppeteer as the way to interact with the page, and Backstop.js to actually do the comparison of screenshots and actual interaction with it. But if I were to demonstrate it to you, I would go back to my Hello America, Hello Country application. So here it will be slightly different. So instead, I would have, I have a Backstop.js already installed, and I would basically just do backstop test. What it would do for me, run it fairly quickly. Great. So basically ran it for me. All right. Actually, let me show it to you here. All right. Anyways, yeah. So if I were to show it to you guys, basically I had 2 scenarios written, and the way you write those Backstop.js scenarios, it looks something like that. It's configuration-driven tests, meaning that you just have a single file. You can have multiple, but for the simplicity, single file that you give a name, then you specify what resolutions you're working for, tablet and phone in my scenario. And then I have different test cases. First test case, I just load localhost. The second scenario I have, I want to just take a screenshot of American flag. Nothing else. I basically say focus on a specific selector. And if I were to look at the test cases that were produced, I would see that, first use test case, the whole app is correct. The mobile, I would not have a flag. If I were to just test the flag in the tablet, it shows me the flag, and in the phone, as you know, there is no flag at all. So not visible. That's great. But now, if I wanted to imagine, let's say, change something, and instead of America flag to be first, let me start with Canada instead. So every time the test runs and the app is up, it will begin with a Canadian flag instead. So let me quickly go here. Exit presentation mode. Okay. So if I were to run backstop test really quickly, it would give me the result. Give it a second. Great. So it basically show me that something has changed. So the reference, the initial flag was America, now it's Canada, and this is a difference. Pretty big difference. But you can notice that the plus part actually passed because, again, we have no flag, we have nothing to compare. And last but not least, imagine I said, oh, this is actually what I expect. The simplicity of backstop is what, again, I really like, is that the only thing I have to do is I have to say backstop approve, and that's all. It basically says, just make sure that Canada is the one you use for going forward. But basically the Backstop.js in practice. But if I were to go further and to actually show you native screenshot testing, it will be still based on the same view loader, action driver, and comparison driver pattern. And to demonstrate you that, I would basically for the Android, you can use something called screenshot tests for Android. Again, the library developed by Facebook. And for the iOS, you could use something called iOS snapshot test cases. Pretty descriptive names, I have to admit, but I would say too verbose. But besides, I would basically demonstrate you the Android framework, the screenshot tests for the Android. And so to show you that, I have to actually go to our Android studio. So for the Android, the app looks exactly the same, almost exactly the same. You still have flags, and you can jump between the countries. So if I were to demonstrate that, for the snapshot tests, the way you would write it is you would first of all, I actually have to mention that the tests here, this native tests, they will be located in the same package as the production code. So the app itself is right here. It doesn't have to, but it can. So in a sense, it has to have access to the low-level references of individual views. To explain that, if you look at the test itself, I have to inflate, if you're familiar with Android, I have to use that R, the reference layout of the Hello America, to be able to load the entire view. Then I take a snapshot and I can record it or compare. So it's very simple, quick test that you can write. This is for the entire app. If I wanted to write it just for the American flag, I would focus on a particular element. So that one, again, is fairly simple. And unfortunately, it's not as fast, especially the first time you run. So I would show you the output of that test. And the output would be something like this. It will tell you what component it tested. And it would also, if I wanted to show you the entire application, it would look something like that. It only focuses on essential views, the label and the flag, nothing else. So if it, of course, if it was to fail, it would be the purple difference that you've seen with other tests. By the way, the purple color is not required. You can change it if you want it, but that's basically the standard that people usually use. But yeah, this is basically as simple as it gets. You load the context, you focus on a particular element, and you take a snapshot of that. So, all right. If you want to talk about enterprise solutions, Screener.io and the Flawless.io is basically one of those couple enterprise solutions. The Screener is the one that has a very good support for React and the storybooks. The Flawless.io is really written snapshot tests for screenshot tests for iOS apps. The Chromatic is also another solution for Storybook. And the Percy.io really does a pretty good component screenshot tests for continuous integration. And the best practices when it comes to component tests is that you really have to care about the screenshot names you have. Try not to call your screenshot A_copy. Give it a descriptive name. Always start with component tests first. Don't go to the page components right away. There is a tool called Git Media that allows you to save the screenshots outside of your main Git repository. So you don't crowd your screenshot in the Git repo. But it still allows you to use the same Git command. It just saves screenshots elsewhere, like AWS or Azure or whatever you like. And last but not least, always respect the test pyramid. Don't just write component tests, start with the unit tests for visual testing. And the overall conclusion of component visual testing is that the domain CSS, those unit tests, is obviously not enough, especially if you're working with the responsive apps. The gap between developers and testers is really getting smaller and smaller. You can notice some of these tools are really pointed on giving the fast feedback to developers so they can actually get working and fixing the bugs before they even get filed. And if you notice a pattern of view loader, action driver, and comparison driver, you can choose a solution that's already out there, or you can develop your own, because the pattern is the same for all these tools. You can write your own if you wanted to. And if you were to finish our journey toward this uphill battle, the responsive testing with the page visual tests, if you were to talk about those, it's obviously something that you can control and have to control the window size, basically figure out what resolution you're working for. You can still test DOM and CSS even with Selenium. You just retrieve the class, you retrieve the style, and you compare it. You can test very nicely different transition states. If you can load the tablet, desktop, or mobile if you wanted to. And you can still take screenshots even with the tools like Selenium. And if you were to demonstrate a tool like that, obviously I would have to use Selenium for this sort of responsive tests. And to demonstrate you that, for example, obviously I have my WebDriver. Oh, let me make it larger, my apologies. Great. So I have my driver. As always, I would set it up. I would use Firefox. I would have my tear down for the driver to be quit. And if I wanted to actually write the test, what I would do, if I wanted to test desktop state of my flag, I would basically say Windows, set the dimension for the desktop, or open up the URL, get me the element, the flag I really want to scan, and make sure the flag is visible so I can still operate and interact with the CSS values. If I wanted to do mobile, the only thing I have to change is the dimensions, And if I wanted to do the transition state, I would basically do the, again, the dimensions. The one thing you could notice that it's very close to those functional tests, but you can still kind of integrate it with these CSS values, and it really helps you with the transition states and just different state for the responsive app. So I always like to have one or two of these, set of these tests, just like a sanity tests, to make sure that the transition between the different platforms behave correctly. I won't be running it because it's a simple driver. It will just open up Firefox. You won't even notice that and validate the CSS, but you got the gist of it. It's fairly simple. But if I were to go to the kind of native visual testing, I would obviously use Appium, which is a great tool for mobile testing, and I would use something called Applitools, basically almost like a de facto enterprise solution for visual tests. So with Applitools, it's a little bit different, but still very close. What I'm trying to show you here is that whatever you've written before for functional tests for WebDriver still can be used here. So if I wanted to demonstrate you that, you would still have a WebDriver, you would have the same setup, except you would have to specify the Appium driver. But one thing is you have to specify the capabilities, where you say, I want to use Android, and I want to use APK that I have, basically the app I've developed. But the rest, for the app tools, you basically, the one thing I like about Applitools is they have very nice API. You basically have eyes, which again, very close to the visual testing kind of semantic. You have an eyes, you specify the API key, and you just set up your driver using the eyes themselves. So if I wanted to actually write the test itself, it would be just these two lines. Eyes, check the window, and eyes close. And what it would do for me, it would basically run this test, and I have the dashboard for the Applitools. What it would do is first test I run, basically take a screenshot of my app, and if I were to run it a few minutes later, it would still take a screenshot, but it would fail because you can notice that the purple color here around the time is different, of course, or even the chart has changed. But the good thing about Applitools is that they allow me to interact with that screenshot and say, you know what, this top level, ignore it. And as a result, I don't have a failure anymore. So Applitools is just generally a tool that really helps you with this sort of test cases for the visual testing. And again, you can integrate it with any sort of platform. The Appium is the way you would test your native application, along with Applitools will help you to go beyond that. So again, enterprise Applitools and browsers Applitools, in addition to the browser stack and the source labs, will help you to basically run your visual test on a scale. There used to be something called test objects. Now it's just called the source labs. So again, you can scale up your visual test if you wanted to. And so here we are at the summit of our uphill battle. And the question is, how are you guys going to use that? How are you guys going to use this test pyramid? And my call for an action for you guys is that really start the climb towards this uphill battle. Start with the visual unit tests, then try to implement some component testing, and wrap it all up with a few end-to-end page visual test automation. So again, just get started. It will be maybe not that simple at first, but as you get started, it will be easier and easier for you. So thank you. And with that, we'll go to the Q&A. Let me see.
Thanks, Dimitri. It was a very insightful session on visual testing. I think we all could start with it in our daily work as testers and acquire not only some basic understanding, but also grow on to build some reasonable skills in this field. And many thanks for sharing the tool details too. That helps a lot. I'm sure our attendees found it very informative and useful too. Okay, so the first question is, please explain why visual testing needs automation. The attendee says that they fully understand and agree that automation for visual testing greatly increases success, but want to understand why you say it is required.
Do you mean the why is it required comparing to the manual, or visual testing as a whole? Why do we need that?
Yeah, why does visual testing need to be automated? Like, why do you say that? I mean, yes, it is required to a certain extent, but
Okay.
it's like you said that manual test it cannot be tested manually at all. So
Mhm.
probably that's the
Okay.
question.
Yeah, I try to prefix that with nearly impossible. The reason why I say that is, again, as I've mentioned, it's not just my personal opinion, it's also the science of it. If it's the main some of the visual regressions that occur, especially between different components when they are integrated, is unintentional, meaning that when I change CSS of one component, especially if you have a component-driven framework, I might have moved another component, another element on a page by 1 or 2 pixels. I would never be able to notice that by just visually. People might say, "Oh, this is not very a big deal." The customer might not have noticed that, but ultimately, as I've shown you with the cracked glass, it would have some underlying issues along the line. And again, as I've shown with the science papers, is that human eye cannot catch those minor changes, those minor visual regressions. I'm not talking about scale at this point, because scale is still obviously will be the concern as you get more and more, the larger and larger. But obviously the fact is those smallest changes, pixels, colors, people can't physically notice those, especially as you grow as the product. It just again, it's as I mentioned, there's so much research done on this topic, and it's been confirmed many times. We cannot see these kind of differences, especially if you look at the same image for a long time trying to find it. Just kind of a waste of time. The one thing I like is that you can do manual, but kind of manual automation. What I like to do as a developer, I install a plugin that takes a screenshot before I do some changes, and it takes a screenshot after I make the changes. So it's still kind of manual, but I still don't use my eyes. When it comes to these pixel differences, you don't want to do that. Not sure if I answered your question, but
Yeah, yeah, no,
we
no,
can
no.
debate more.
Perfectly. Yeah, you perfectly answered it. But can I safely say then that there is a part which can be done manually, but the moment it gets more detailed and complicated and repeated, and maybe at a higher scale, like too many screens at a go, then automation is the way to go?
Oh yeah, of course. Like you always start manual. Like with any
Yeah.
test cases, there's always the beginning where you do manual stuff. It just as you kind of put regression suite in place after you already tested everything manually, you obviously don't want to keep doing that all over again and again manually. You would do it manually first and then
Mhm.
automate it. Yeah.
Yeah, yeah, that makes sense. Yes, thank you. Okay, so our next question is resolution, screen size, and dimensions sometimes confuse me. Where I can learn deeply, like more practical details on these.
Especially, yeah, I would agree that it's confusing, especially with different APIs using different words for the same thing. I would say, for honestly, when you write the automation, it doesn't matter as much as long as you just work with whatever API you have. Because if you have a set dimension, you won't have an API set resolution. So technically speaking, these terms different, but when it comes to actual automation that you write, it all depends on the tool you use. In one tool, as you've seen today, it will be called dimensioned. In some, it will be resolution. In some, it will be size. So it's not, when it comes to writing actual tests, it doesn't matter for you. It still will be the same two values that you see in the developer console versus what you see in the API. So I wouldn't go into technical terminology. Just look at whatever API you use for tests themselves, and it will be ultimately the same two values. It doesn't really matter what it is behind the scene. It's just whatever API you use, whatever it's called there.
Okay, I'll just take one more question because we are now running to the time. The tools which you showed before Apply tools, would those need
Mhm.
access to dev code as well?
Mm, let me think. So Jest, uh, I would guess so. Yes, the backstop JS doesn't have to. Phantom CSS doesn't have to. Um, I would say most of them don't really need that. It just the reason why some of them kind of use good to have near the code base, it's because developers don't like, as I've shown you before, one of the points I've made, that the gap between developers and testers is kind of, narrowing lately. And so people usually have test and the developer code in the same kind of package almost. Obviously, test and dev is slightly separated, but in the same code base. And this is what I'm proponent of. But ultimately, you don't have to have a test dev code near the test code all the time. But many of these tools would be very handy to have in the same kind of package. That's what I would propose. But yeah, to answer your question, no, you don't have to.
Thank you. Thank you, Dimitri. So
thank you.
We'll be,
Thank you for joining.
Oh, thank you. All right. Everyone, this concludes our webinar for today. Thank you everyone again for joining, and more importantly, thanks for being engaging and making the most of the webinar for yourself and the whole group. If you want to see more such sessions from speakers like Dimitri and others, and wish to learn more about visual testing related subjects, do come over to STPCon Fall 2018. All right, and stay tuned for more webinars and online trainings coming soon at SoftwareTestPro.com. If you haven't signed up yet for the upcoming webinar, which is Entrepreneurship in Software Testing on 25th of July, where 3 leading test professionals turned entrepreneurs are sharing their stories, and please go ahead. The link is up for registration. Okay, thank you everyone. Have a great week ahead. See you all in Virginia in October 2018. Happy learning to all of us.
Thank you.
Thank you.